So I sent you this problem earlier and I wanted to give you a chance to solve it yourself. I'm going to go ahead and solve it step by step so you can see how I do it anyway, okay? So the earlier problem I gave you, I used these two colors to kind of show you, if you remember, my resistor was here, right? And it was very easy to see that when I got here, the current had to split. Well, this is the exact same problem. All I did was slide my wire over and bend that leg. So it is the same problem as earlier. So I'm going to do the same thing. I'm going to take and find how much resistance is here between these two, a parallel of R2 and 3. I have two like resistors, same value. So I take 80 divided by 2, there's 40 equivalent resistance between these two resistors. In series with 80 ohms. In a series, I just add the two values together. I have 120 as R total. So now that I know R total, I can say that E divided by R is I, right? So I have 120 ohms divided into 240 volts. I have 2 amps in this circuit total. So my 2 amps is flowing in this direction. When I get to this node, there are 2 directions that can be taken. I know that part is going to go this way and the rest will continue in this direction, coming back and recombining here. That recombination of the 2 amps means that there are 2 amps at R1. I now have 2 out of 3 factors for Ohm's law. E equals I times R. So I have 160 volts right here. If I looked at it here, 160 volts. I know that in series, I must drop the total voltage that's being applied. So if I have 240 to begin with and 160 is here, that means that there are 80 volts on this parallel portion of the circuit. If I take and separate those 2 resistors again, I have 80 volts here and 80 volts here. I can get I, which is E divided by R. 80 divided by 80, 1 amp went this way, 1 amp went that way. So my E1, 160, 80, 80, 2 amps, 1 amp, 1 amp, 80, 80, 80. That's it.